Okay, we have here today a pretty scary looking integral. We have the integral from 4th root of 2 to the 4th root of 5 of x cubed cosine x to the 4th cosine 7 minus x to the 4th plus cosine x to the 4th dx. Okay, now we've got a lot going on here, so I want to just try to focus on seeing if we can do something to simplify this situation. And I notice we've got x to the 4th here in 3 different places. Now the nice thing about that is the derivative of x to the 4th is 4x cubed, which looks like a u substitution might help us out. So for my u substitution, we'll just call u equal x to the 4th. Then from here, we'll just take that derivative. du is going to be 4x cubed dx. And then to make it easy on myself, I'm just going to create this 4 here so that I'm matching my du. I'll multiply by 1/4 out front, so I'm just multiplying by 1. Then we'll just go ahead with this substitution. So the interesting thing with the bounds, if I plug in the 4th root of 5 to x to the 4th, it's going to take the root away and we're just going to end up with 5. And the same thing here, the 4th root of 2 to the 4th is going to give me just 2. Then again, this piece right here is going to be just our du. So for cosine x to the 4th, we're going to have cosine u du. Now for this, it's going to become cosine to the 7 minus u, and then we're going to have another cosine of u. And now at this point, I'm noticing if we just add up these bounds, if we add 5 and 2, we get this 7 here. And so it's actually looking like King's principle is going to work on this. Now I'm going to make another substitution. We could use x again, that's not going to be a problem, but I'm going to use t just to make it less confusing. So for t, we'll add the bounds. 5 and 2 is going to give me 7 minus u for our t. So that's going to simplify that. But then if we get an expression for u, that's just going to be 7 minus t. Then I'll take a derivative to get my du value. So that's going to give me du is going to equal to minus dt. And then we'll go ahead with this thing. So we'll have our 1/4 out front still. I plug 5 in here for the substitution. That's going to give me 2 for the upper bound. I plug 2 and I get 5. Then for cosine of u, that's going to be this thing. So we're going to have cosine to the 7 minus t. This thing here is actually going to become t. So we have cosine t plus, again, this is going to be the same thing, 7 minus t. And let's not forget that minus sign in front of the dt. But right away what I'm going to do is I'm going to take that minus sign, I'm going to bring it out front, and I'm going to use to swap my bounds. So we're going to put the bounds back, flipping them, we're going to put it back to integrating from 2 to 5. But now at this point we notice that this and this are really the same thing. You know, we swap the order, different variable name, but that's not going to matter because what I can do is change the variable name because we have a definite integral. So what I can do is change this back to u. So I'm just going to rewrite this whole thing just in u. Now at this point what I'm going to do, I'm just going to take this integral, backing up a little bit. We'll take this one and this one, and we're going to add them together. And what I'm going to do is just make a label on these. So what we'll do is we'll call, now our original integral we'll call I, but all we've done is manipulate this. So this is an I and this is an I. So when I add them together, we end up with 2i. I'm going to factor the 1/4 out front. When I do this, we'll have 1/4 out front, same bounds, and then we'll just add this to this. But now at this point, we're in really good shape because this thing just cancels out and we're just integrating 1. So when I do this, we'll just integrate this. We'll just integrate 1. We're going to get u evaluated from 2 to 5. Well, when we evaluate this, we'll have the 1/4 out front. We're just going to have 5 minus 2. Of course, that's 3. And so this is actually going to be 3 over 4. But just one more thing to finish it off, we can't forget that we actually have here 2 copies of the integral. So I'm just going to divide by 2, divide by 2. So what I'm going to do is just carefully bring this up here. And so for our final solution, we just have 3 over 8. Okay, good problem. I got this one from my quiz, King's Rule Integrals. I'll provide a link in the description if you want to check out more problems like this. And we'll stop it there. Thanks everyone for watching. Have a great day.